By now you've learned how to take a trinomial and factor it into two binomials. Well, once in a while, you've got to factor one more time for it to be completely simplified, and that's what we're going to go through today. Here's our first situation. When your leading coefficient is negative, you want to get rid of that negative. Now, it's going to be part of your answer, so you can't completely get rid of it, but it's going to make life a lot easier for you. And so what I'm going to do is I'm going to change this to that negative to a -1, and then put in here what's left over. Well, -1 times what gives you a -6v squared? 6v squared. -1 times what gives you a -11? +11. I mean, you were really basically, all you're doing is just changing the sign of everything in the inside. There you go. I just changed the sign of everything, but kept that -1 out. Now, I'm going to remember that -1, but right now I need to finish this middle part. And so just like before, I'm going to take the 6 times the 4 and get a 24. Find the factors of 24. That will add up to 11. And nope, I can stop right there because I just found them right here. And let's go ahead. Now, I'm going to not put the negative at the moment. I'll get back to that in a sec. I'm just going to do this middle part. So 6v squared plus 3v plus 8v plus 4. And if you're a box person, you do this with a box, then go ahead and do it with the box. I'm going to just do it with the grouping method. Looks like I'm going to pull out a 3 and a v. And I'll have a 2v plus 1 left over here. And I can pull out a 2, and I should have a, not a 2. You know what? Hey, I want to show you that for a second. I am going to pull out a 2 and show you that I have a 4v plus 2. And the first thing you should look at is go, whoa, wait a minute. These two don't look alike, and you're correct. But look at the second one. Notice how both of those numbers could be divided by a 2. I did not pull enough out when I did that. So let me go ahead and fix that a little bit here. Okay. And I can pull out a 4, actually. And then I get a 2v plus 1, and oh, good. Those two are the same. So now I'll put the 3v plus 4, and I'll put the 2v plus 1, but I'm not done. Because remember, I said we have to remember that negative sign way over here. And then I'm just going to put it right here, and I'm done now. So basically, if you ever have a negative number at the beginning, pull it out. It's going to be the first little thing that you have there when you're done with your answer. And then with the rest of the trinomial, do what you normally do. Pause the video, do this one on your own, and then come back and see how you did. Here we go. I'm going to take the -1 out, and then inside I'm going to have the opposite signs of each of these, plus 6. Then I'm going to just do what I do normally. 2 times 6 is 12. Factors of 12, that add up to 7. And, well, -7. And since that's a positive 12, both of those have to be negatives. Then I'll write 2p squared minus 3p minus 4p plus 6. If you don't know how to do this by now, you do need to go back to one of the earlier videos to understand why I'm doing what I'm doing here. Minus 3. So I have a p minus 2 and a 2p minus 3. And then I'm going to take this negative and I'm put it right here because it's still part of the problem. We just pulled it out so that we could do the rest of it. If you look at the 3 numbers in the trinomial and you go, they're all multiples of the same thing, then pull that out. Pull the greatest common factor out to start with. And do you see that all 3 of these can be divided by a 6? Sure. So we're going to pull the 6 out and then put what's left over. So x squared minus 2x minus 3. And then just like the negative, I'm gonna remember the 6, but right now I'm just going to ignore the 6 for a moment. And I'm going to do this part. Okay, the factors of -3 are just going to be 1 and 3. Either 1 and -3 or -1 and +3. Because you have to have a negative or positive to get there. All right, which one is going to add up to be -2? This one right here. So I'm going to do an x squared minus 3x plus an x minus 3. Pull an x out. We have x minus 3. Pull a 1 out, x minus 3. And you will get x plus 1, and x minus 3. But again, don't forget, you pulled out that 6. That 6 is still part of the problem. So we're just going to put it right here in front of this set of parentheses, and there's your answer. Go ahead and try this one on your own, and then come back and see how close you are to being right. Okay, hopefully you saw that you could divide all of these by a 9, like this. And I would have the 9 out, and then x squared minus 4x plus 3. Now I'm just dealing with this. Let's see, the factors of 3 that add up to 4. Well, that's just 1 and 3. Negative 4, so both of them have to be negative. Negative 1 plus negative 3 is negative 4. Then I'm going to do the x squared minus 1x minus 3x plus 3. That's just an x minus 1, negative 3, x minus 1. And so my final answer should be x minus 3, x minus 1, and then that 9 has to be in front because he is part of the problem. So let's say that's not how you did this problem. Let's pretend you actually found the factors of, I think, 243 that added up to negative 36. And you did all your work, and you got something that looked like this. 9x minus 27 times x minus 1. Would that be wrong? Well, yeah, it's not completely simplified yet. And the reason is because in this first trinomial, I can still pull out a common factor. I can pull out the 9. And so I would do that now. And I put that 9 in front. And then this would become an x. That would become a negative 3. And then x minus 1. And so you would get to the exact same right answer. But it would, I mean, seriously, did you really want to find the factors of 243? Yeah, not me. I'd rather pull out the greatest common factor out first and then play with the numbers. Can you see what needs to be factored out here? Yeah, it's pretty obvious. They all have a 5. So I'm going to divide by 5, divide by 5, divide by 5. And I'm going to get a 5x squared minus x minus 1. At this point, I'm looking for factors of negative 1 that add up to, well, negative 1. Well, that's 1 times negative 1. But that's the only thing I can have to get negative 1 is 1 times negative 1. But when you add those together, you get a 0. And that's where you have to know when to stop. Sometimes when you pull out the greatest common factor, you're done. And this is one of those cases where there is nothing else I can do. He is as simplified as possible. All right, go try these and have some fun.